Okay, let's continue. Well, now we are going to start from a binary search tree, and we want to decide how should we color this tree. And as you can see, we have already added the null pointers as a fake news, no, not fake news, fake nodes. Okay, so all the black dots, they are just null pointers, and we have already colored them into black. And after that, we want to color all the real tree nodes. And here is one solution. So if you check all the properties, so number one, all the colors, all the nodes are colored to red or black. That's okay. And number two, all the null pointers are black, and that's good too. And number three, if a node is red and both children are black, and the only red node is 12, and as you can see, both of the children are black, so number three is not broken. And let's check number four. Number four is usually the trickiest. So if we go down by from one direction, if we go from here and here and here, so oops, you will count a total of three black nodes, right? And if you want to do another one, 7 to 5, 5 to this now, you count 3 as well. So no matter which way you go, and you will count there are 3 black nodes guaranteed. So this is a valid red-black tree, it seems. And the last one, the root is always black. And as you can see, 7 is black. So far, we have a valid red-black tree. Okay? So the next part, if you want to do an insertion, if you want to insert an 8, where does it go? You may ask, wait, we haven't talked about the insertion of the red-black tree yet. Well, but remember, a red-black tree itself is a upgraded version of binary search tree. So the rule of the insertion works quite similar to the binary search tree. So if we want to insert 8, we visit root, and then 8 is greater than 7, so we go to the right side. And then we visit 9, and 8 is smaller than 9, so we come here. And here we have a empty slot. This position is currently held by a fake leaf. So it is okay that we just put the 8 there. And the next thing is, after we put the 8 there, what color should we put to the new node? So you may find a red should be fine. But before I color that to red, let me ask this question. Why we can't color the 8 into black? Think about it. Or if we color the 8 with the black color, which rule are we gonna break? The answer is number 4. So if we color the 8 into black, and then from 7 to 9 to 8, and then to this now, we count a total of 4 black nodes. However, 7, 5, and here, and now we count 3. So this means if we color the 8 with the black color, we are going to break the property number 4. But if we color that to red, we are not breaking anything. Okay, so we insert 8 and we color it as red, and so far so good. Okay, the next part. How about 11? If you want to insert 11, and 11 goes here. Okay, the question again, how can we color 11? If we color 11 as red, is that okay? The answer is no, because 12 is already red, and then if 11 is red again, and then we have 2 consecutive reds, and that is not allowed. It will break the rule number 3. Okay, how about black? If we color 11 as black, can we live with that? The answer is no. So if 11 is a black, and then 7 to 9, 9 to 12, 12 to 11, and 11 to this now, we count total of 1, 2, 3, and 4. So the black height will be 4 from 7 to this now node. However, if you check other passes and the black height is a 3, so we are violating the property number 4. So it can be red, it can be black. How can we do? Okay, we can recolor the tree. So here is a tree. Here is a trick. So we have two consecutive blacks. Two consecutive blacks is allowed in the red-black tree. However, since we are growing heavier on one set, one thing we can do is we change the 9 to black, and then both of the children will we change 9 to red color, and then both of the children 8 and 12 will be black. So in this case, if you go down 7, 9, 12, 11, and this one, okay, we count the black height as 3 again, right? So for this version, no matter which way we go, and then we only have 3 black nodes to visit. Okay, I want to pause here for now. So I want to ask you this question. What is the shortest path from the root 7 to a leaf? I mean a fake leaf. You can find it is this one. 7 to 5 and 5 to the fake leaf. So we are visiting only 3 nodes, and those 3 nodes are all black. Okay? So the next question, what is, let me say, so 3 black and 0 red. Okay? This is the path. This is the shortest path. So let's take a look on the longest path. So the longest path should be 7 to 9, 9 to 12, 12 to 11, and 11 to this now. Okay, so if we count the number of the black nodes, that is 3 blacks, right? And how many red do we have? So that is 2 red already. So this means if we want to grow this tree on the left side, we can potentially add a node between 5 and 7. We can potentially add another red node here, right? So this is how we can possibly grow a tree. If the tree grows, we need some more space to grow. Well, the safest thing is we can insert a red node right between 2 blacks. So in this way, we have the space to accommodate one more node, one more red node, and yet we don't break the property number 4. Okay, so the next question, how about a 10? So a 10 should put here, of course. And then how do we color that? If we color that as red, no, it doesn't work because we cannot have 2 consecutive red colors. How about we color the 10 black? If we color the 10 black, it seems that it's okay, but actually it breaks the rule of the number 4, because if the 10 is black, so 7 and then 9, 12, and then 11 and 10, and finally this node. So we count 4 black nodes again. But remember, just now we say there can only be 3 black nodes. So you see the problem. When we have the right subtree is already heavier than the left subtree. Okay, and the right subtree, the longest path, is already 3 black and 2 red. If we add one more node, we are gonna have a trouble because we can't color that black, we can't color that as red. So why? The reason is now this tree is really imbalanced. There's no way that we can fix this tree because this tree is super heavy on the right side and light on the other side. So our task for now shouldn't be colors and nodes. We have to rebalance the tree. Okay, so our next goal will be we want to figure out the way that we can restructure the tree with the old login time, because for this version of the tree it is super imbalanced. Okay, so I will see you in the next video.